Hello everyone. Today we are going to be taking a look at Chapter 15.2, Pollution of the Atmosphere. Our guiding question today is, what are the sources of air pollution? By the end of the lecture, you should be able to explain how both natural processes and human activities can cause air pollution. Describe how air pollutants affect human health. Explain what causes smog and how temperature inversion affect it and other forms of air pollution. Explain how acid deposition occurs and describe its effects. Go ahead and take a few minutes to write down the following definitions in your student workbook. When you're done, come back and we will continue on with lecture. Lesson 15.2, Pollution of the Atmosphere. Air pollution is estimated to cause 2 million premature deaths worldwide every year. So we'll go ahead and continue on to discuss how and why that is. Sources of air pollution. Air pollution can be caused by both human activities and natural processes. Air pollution is the release of damaging materials into the atmosphere. The substances released are called emissions. Some emissions, such as smoke and soot, consist of tiny particles or particulate matter. Others are gases, such as sulfur dioxide and carbon monoxide. Natural processes produce a great deal of the world's air pollution. Winds sweeping over dry land can create huge dust storms, as seen in the figure. Winds sometimes blow dust across oceans from one continent all the way to another. Volcanic eruptions release tiny solid particles and gases into the atmosphere. Fires in the forest and grasslands also produce smoke, soot, and gases. Human activities can make some natural pollution worse. For example, some farming and grazing practices strip most plants from the soil. When there are few plant roots to hold the soil in place, wind erosion may occur. Wind erosion can lead to these dust storms that we see. Human sources. People's activities have influenced air quality. The way we live, for example, our industries, the cars we drive, and the way we produce electricity has introduced many sources of air pollution. Air pollution can come from point sources or non-point sources. Remember, point sources are ones you can identify the source, and non-point sources are more general and is harder to define exactly where the source of pollution is coming from. In London, power plants and factories act as a point source of emission. Millions of cars and trucks together make up a moving non-point source. Most air pollution comes directly or indirectly from the combustion of fossil fuels. Fossil fuels are carbon-containing fuels that form millions of years ago, presumably, from the remains of living things. Motor vehicles, such as cars and trucks, run by burning fossil fuels. Motor vehicles release an enormous amount of pollutants into the air. Types of air pollutants. There are primary and secondary air pollutants. Pollutants may do harm directly, or they may cause a chemical reaction that produces harmful compounds. Primary air pollutants, such as soot and carbon monoxide, are pollutants released directly into the troposphere. Primary air pollutants may cause damage themselves, or they may react with other products to cause damage. Harmful products produced when primary air pollutants react chemically with another substance is called secondary air pollutants. Secondary air pollutants include tropospheric ozone and sulfuric acid. The table below describes some primary and secondary pollutants. Remember, primary air pollutants are released directly into the troposphere. Secondary air pollutants, in contrast, are the products of chemical reactions between the primary air pollutants and other substances. You can read through the primary air pollutants on your own, but I will mention a couple. First, there's carbon monoxide, CO. It is a colorless, odorless gas. The source is primarily from incomplete combustion of fossil fuels or by motor vehicles, industries, and including other sources. The effects that it has is that it binds to hemoglobin, which is in your red blood cells, and they are the oxygen-carrying chemical, and the result means that your body is being deprived of oxygen because carbon monoxide will bind to those receptor points more readily than oxygen, stealing its place and preventing you from being able to have the oxygen required for respiratory. Next, nitrogen dioxide is a foul-smelling reddish-brown gas that belongs to the family of a compound called nitrogen oxides. A reaction between atmospheric nitrogen and oxygen is combustion engines and during the production of electricity. This can cause serious lung irritation, which contributes to smog and acid precipitation. Particulate matter, solid or liquid particles that are small enough to float in the atmosphere, like soot, dust, and tiny bits of metals, are generated from dust being blown by the wind, soot and chemicals produced by fires and combustion within engines, particles produced during construction and farming. All of these can be inhaled and can ultimately affect breathing and damage the lungs. Taking a look at secondary air pollutants. First, we have tropospheric ozone. Remember, ozone is only considered a pollutant when it is found in the tropospheric layer. It is a colorless gas with an unpleasant odor. It results from the interaction of sunlight, heat, nitrogen oxides, and volatile organic compounds. Ozone's effect in the stratosphere protects humans from radiation, but the ozone that is found in the troposphere can injure living tissue and cause respiratory problems. Sulfuric acid and nitric acid are produced when sulfuric dioxide and nitrogen oxides combine with water in the atmosphere. These are the components of acid precipitation, or acid rain, which we will look at further later. Go ahead and look in your workbook and answer the true-false section and questions 1 through 3 and 5 through 8. Take a look at the image above. You can see that the runner here is taking precautions to reduce the amount of air pollutants that he inhales during a marathon. Now we're going to discuss in a little bit more detail how exactly air pollutants affect our health. We saw on our table that they can have a direct link to lung problems or breathing problems. But how and why? Outdoor air pollution is a big health problem. Air pollutants can do serious harm to the respiratory system, which transports oxygen into your body and removes carbon dioxide. Some air pollutants can even cause cancer. Respiratory system problems. Have you ever inhaled dust and then started coughing? Particles in the dust irritated your respiratory system, making you cough. Similarly, air pollutants irritate people's air passages and lungs. If people are exposed over and over to air pollution, they may develop harmful respiratory conditions, which include asthma, bronchitis, and emphysema. What are the effects of carbon monoxide? Well, how do the cells of your body obtain the oxygen they need? The air that you inhale contains oxygen. This oxygen passes from the lungs into the bloodstream. There, oxygen binds to hemoglobin, the molecule in red blood cells that combines chemically with oxygen. The red blood cell then carries the oxygen to the cells throughout the body. However, if there is carbon monoxide in the air, the carbon monoxide will bind to the hemoglobin, replacing some of the oxygen that the blood would normally carry. Therefore, carbon monoxide interferes with your body's ability to deliver oxygen to cells. This can cause headaches, tiredness, and nausea. Over time, carbon monoxide can damage the heart because the heart muscle has to work harder than normal to deliver the oxygen required. In high concentration, carbon monoxide can even be fatal. Cancer. Trace amounts of some air pollutants may contribute to cancer. Soot, for example, can cause cancer if it is inhaled frequently. Benzene, which is a volatile organic compound in gasoline, has also been linked to cancer. Exhaust from cars and trucks also contain benzene. Go ahead and look at workbook questions 9 through 11. Now we're going to look at smog and temperature inversions. Key concept: temperature inversions may trap smog close to the surface of Earth, preventing the pollutants from dispersing, which means spreading out. If you combine the words smoke and fog, you get the word smog. Smog is an unhealthy mixture of air pollutants that may form over cities and nearby areas. There are two types of smog: industrial smog and photochemical smog. First, we'll discuss industrial smog. This is the smog that covered London in 1952. Industrial smog is produced when soot combines with sulfur compounds and water droplets in the air. Because of government regulation, this type of smog is far less common in developed nations than it was 50 to 100 years ago. However, the situation is different in developing nations, such as China and the nations of the Eastern Europe. Industrial technologies in these nations are often older than those in developed nations, and have less ability to control pollution than do newer technologies. Also, there is less government regulation of air quality in those nations. Therefore, industrial smog continues to create health problems in many areas. Photochemical smog. A photochemical process is one that needs light. Photochemical smog is a thick brownish haze that forms when sunlight acts on a certain air pollutant, such as nitrogen oxides and chemicals called hydrocarbons. Tropospheric ozone is often the most abundant pollutant in photochemical smog. Ozone in the troposphere is chemically identical to ozone in the stratosphere. However, unlike ozone in the stratosphere, which protects living things by filtering ultraviolet lights, tropospheric ozone can damage living tissue, especially the eye and lung tissue and plant leaves, as well as some other materials. The main source of pollutants in photochemical smog is the exhaust released by cars and trucks. Governments are acting to reduce motor vehicle emissions, which will reduce photochemical smog. For example, vehicle inspection programs make drivers fix cars and trucks that release high levels of pollutants. Next, we're going to look at temperature inversions. Recall that in the troposphere, air temperature usually decreases as altitude increases. Earth's surface warms the air at low altitudes. Since warm air rises, any pollutants in the air are carried away from the surface and higher into the troposphere. This process removes pollutants from low altitudes and helps them disperse. The situation is different, however, when a temperature inversion occurs. A temperature inversion, or thermal inversion, is the condition in the troposphere in which a layer of cooler air is located beneath a layer of warmer air. Since cold air has a higher or greater density than warm air, the air at Earth's surface does not rise and mix with the air higher up. Therefore, temperature inversion can keep air pollutants, including those found in smog, from going away. In your figure, it shows how a temperature inversion can worsen air pollution. It was a thermal inversion that caused London's killer smog of 1952. Inversions regularly cause smog buildup in some cities, such as Los Angeles and Mexico City. Looking at the images on the slide, we will see that normally tropospheric temperatures decreases with height above the ground. Looking at the first figure, normal conditions, we see that air at the surface mixes with air above it. In the temperature inversion in figure B, cool air stays near the ground under a layer of warmer air and little mixing occurs. Critical thinking. Why do you think temperature inversions, such as the one that occurred in London in 1952, make air pollution worse? Well, to answer that, look at figure B, and you can see that this inversion layer prevents air from mixing at the different layers and traps the pollutants right above the city. Acid deposition. Key concept. Acid deposition results when products of combustion combine with water, oxygen, and other substances in the atmosphere. When some pollutants combine with water, oxygen, and other chemicals in the atmosphere, they form compounds called acids. These acids may settle to the surface of Earth as acid deposition. Acid deposition may consist of solid or gaseous particles, or the acids may dissolve in fog or precipitation. Acid precipitation is sometimes called acid rain. But any kind of precipitation, such as snow or sleet, can contain acidic pollutants. The pH scale and precipitation. The pH scale is used to measure whether solutions are acidic or alkaline. The value on the scale range from 0 to 14. A pH of 7 is neutral. That is, it is neither acidic nor alkaline. If a solution has a pH that is higher than 7, it is considered alkaline, or another term is basic. An acid is a solution whose pH is lower than 7. The lower the pH number, the higher the acidity. The pH of precipitation varies. Normal precipitation is slightly acidic, with a pH of about 5.6. Acid precipitation has a lower pH. Some areas in the United States have a precipitation with a pH as low as 4.3. What are the sources of acid deposition? Acid deposition starts mainly with sulfuric dioxide and nitrogen oxides. These pollutants are produced largely through the burning of fossil fuels by automobiles, electric power plants, and industries. In the troposphere, these compounds can react with water, oxygen, and other substances to produce acids such as sulfuric acid and nitric acid. Wind can carry pollutants over long distances. Therefore, acid deposition may fall on areas that are far from where the pollutants were produced. For example, much of the pollution that is produced in Pennsylvania, Ohio, and Illinois falls out in the states to the east, including New York, Vermont, and New Hampshire. What are the effects of acid deposition? Well, it can be harmful to the ecosystems and structures that humans have built. For example, if the pH in lakes becomes too low, neither plants nor fish can survive. Acid deposition can kill trees and destroy entire forests. When acid gets into the soil, harmful chemicals can be released. These chemicals can poison the plants growing in the soil. Acid deposition can erode the surface of stone buildings and statues. In addition, acid deposition can increase the acidity of the water that comes into your home. Water with increased acidity can pick up harmful chemicals from metal pipes and contaminate drinking water. Acid deposition is a problem, but it can be solved. People and governments have taken steps to eliminate or reduce air pollutants that cause acid deposition. The next lesson will describe some of those steps. Reviewing key concepts. First, air pollution can be caused by natural processes and human activities. Next, air pollutants can damage the respiratory system, interfere with the body's uptake of oxygen, and cause cancer. Temperature inversion may trap smog close to the surface of Earth, preventing the pollutants from dispersing. And lastly, acid deposition results when products of combustion combine with water in the atmosphere. Please make sure to complete Workbook Chapter 15.2, number 1 through 3, 5 through 8. And 9 through 14, and number 17.